welcome you to the second in the series of the RCMI Research Forward webinar series. And we want to encourage you to come back, watch your email, and come back for each one of these series. We think they'll be very, very informative and helpful to you for your research productivity. And each event has a particular topic or theme, and today's topic is big data, data science. And we have two speakers, Kwazi Yeboah Afahini. Dr. Yeboah Afahini received his PhD in data science bioinformatics from Rutgers University, and he joined Howard a few years ago in the hospital doing some bioinformatics data science work, and we recruited him within the last few months to work with RCMI, particularly in the area of data science, and as it relates to clinical informatics primarily. And so he'll be talking to you, and also talking to you is Dr. John Quajan. Most of you probably know John. He's been associated with RCMI for a while, and he is a biostatistician background, and he also has data science expertise. And I'm also pleased to announce to you to be looking out for RCMI announcements, because John has just received a data science training award from the National Institutes of Health, where he will be leading a group of folks providing data science workshop-based virtual workshops and over for about 8 different topics, but he'll probably talk to you about that some as well. So we're excited about that. And so today's two speakers are Kwazi Yeboah Afahini and John Quajan. Both of them are very good experts in the data science field. I think we're going to start with Dr. Yeboah Afahini first. Am I right? Okay, Dr. Yeboah.
Correct.
Okay, Kwazi.
Thank you very much, Dr. Sutherland, for the introduction. And thanks to every one of you also for your time and participation in the RCMI webinar series. I'm going to be talking about big data. And primarily by the end of it, we will have a very good bird's eye view of what big data is, as well as what we can do with it and where we go from here. And also we're going to be talking about some tools that is in the industry that is being used for analysis and visualization, as well as the entire end-to-end processing of big data. We'll be talking about some challenges of big data, and also why big data is so much of a buzzword today. The opportunities in healthcare that big data offers, and the role of big data technology in research. And then we culminate into RCMI community and big data. Okay. Today we can see big data coming at us from all different angles, all different directions. Data from science, from retail businesses, from entertainment, from healthcare, finance. It's all over. Even from home appliances and devices we wear, like Fitbits and all. Data is all around us. And they contain a gem of information and insights, only if you can harness it. I'm having a bit of difficulty switching from slide to slide. Okay, so these are the characteristics of big data. It's called big not only because it's voluminous, though it is sometimes. It spits at us at a very high rate, and it's very noisy. Sometimes it's very inconsistent, and this gem comes from visualization, graphs, and charts. And the real value is in the insights that they share and inform critical decisions. And also, it comes in many different forms, many types of data. Some are tabular, free text, video and audio, and also social media, text, and other information formats. Hello?
Would you like me to control your slides for you?
Yes.
Okay.
Yes. Okay. There are a lot of tools out there that are used to analyze big data, some of which is Xplenty, which is a cloud-based data integration tool. A very powerful tool in that it integrates data from all different sources and types and prepare it for visualization and so on. Apache Hadoop is a data processing tool for big data, as well as IBM Watson, which is a tool which translates data into knowledge and insights. CDH is another distribution of Hadoop, and Apache Cassandra is a DBMS, though it's not relational, as we know DBMS to be. It's used for storing unstructured data. Can you go to the next slide, please? The 9 big data is also a tool for data integration, but it particularly prepares data for the 9 analytic platform, which is a platform used for analyzing data and creating very insightful analytics. Data Wrapper, MongoDB, they are tools that are used in the data science, big data area. MongoDB is also a DBMS tool, which is used for storing web data in a JSON format. Nmap is a very interesting tool as well. It's a GIS solution which has a big global reach. It takes information instantaneously and analyzes it into visuals that holds a lot of insights. Later, I will show you a slide which is a snapshot of MapD's screen. That will give you an idea of what MapD can do. Can you move to the next slide, please? There are several challenges with big data because of its nature and how fast it has to be processed to make it relevant real time. The speed of processing is one of them. The storage capacity is another. But there have been solutions out there to mitigate the risk of those those challenges poses. For instance, storage capacities are no longer an issue now because of cloud computing, as well as compute power of computers, also not an issue right now because of cloud computing. So big and small businesses can both capitalize on the gem of big data analytics. Though even though the small ones may not be able to create their own in-house architectures for them. Could you go to the next slide, please? One of the touching issues in big data is security. Everybody know, I just noticed a spelling check, a mistake here, hacking. It should be CHACKRN. G. Could you please correct it later for me? Security is a big issue in big data because there are hackers all over the place trying to steal information. But fortunately, there are some encryption technologies out there which kind of helps resolve some of those issues. Some of the technologies are randomized data encryption, deterministic encryption, and order preserving encryption. I'll just illustrate them with an example to make it easier to understand. Randomized data encryption, for instance, if there is a document out there with pertinent information about myself, such as my social security number, and my social security number appears in the document a couple of times. What randomized data encryption does is it then selectively encrypts the sensitive data, such as my social security number, and create a ciphertext for it so that it becomes useless for those who steal it. And for all the instances of my social security number, for the randomized data encryption, it will create different ciphertexts for every social security number. So that on the other side, it needs to be ciphered with different keys in order to make it meaningful or visible again. For deterministic encryption, with the same example of document with my social security number, all the instances of the social security number will be encrypted with the same ciphertext. What that means is that on the other end, it will be decrypted or will be deciphered with the same key, which is a little bit easier than deciphering a document which uses the randomized data encryption. So practically, most people use deterministic encryption, which is a little bit more practical, a little relatively easier to work with. Order preserving symmetric encryption is a deterministic encryption technology. The only difference is that the order is preserved. For instance, for all the 4 different social security numbers in a document, the first will be preserved, the order will be preserved. The first instance will be preserved, the second, the third, the fourth, and the fifth. So that every instance will be a particular exact, well, will be determined. Once you pick one, you know it's the first instance and where it appears in the document. 2, you know it's the second instance in the document, and so on. So the only difference between the deterministic encryption, the generic, and the order preserving is that the order which the plain text appears in the document is preserved. Could you go to the next slide, please? Could you go to the next slide, please? Yes. So why is big data such a big issue now? Why such a big buzzword now? It is because of a precision decision making. There used to be a lot of abstraction in decision making, which makes it a little bit risky in terms of getting the right or expected outcomes. But big data kind of take a lot of the guesswork out of it and give a lot of information and insight that helps the decision makers to be more precise, though it's not exact in terms, it's not an exact science, but it takes a lot of the guesswork out of decision making. And the need is out there because it's a huge competitive edge for most organizations in many different industries. Without it, you'll be playing a lot of guesswork, which will put you at the end of at the worst end of the competition. Data is also very abundant today, and it comes in different sources, and it's all over the place. So data itself is not an issue at all today. Compute power is also not an issue because of cloud computing. And there are several technologies out there that enables quick and fast processing of data these days, which also make compute power not an issue. Such hardware technologies like GPU, main core, and flash memory helps to process data instantaneously, almost, in computers or systems that have such technologies. And it's all out there. And besides, it's becoming cheaper and cheaper. So all these issues is enabling the big data revolution. Can we go to the next slide, please? Now, healthcare. We all are aware of the inefficiencies in healthcare. There's a lot of waste in healthcare, especially in the United States of America. If you take at the micro level for organizations and at the macro level, at the country level, when you take the per capita cost or per capita expense, healthcare expense in the United States, and compare it to other countries of equal developmental state, in the equally developed countries, the United States numbers far exceed the per capita expenses, healthcare expense of these countries. But our outcome doesn't commensurate the expenses that we make on healthcare per capita. Those countries don't spend less, have better outcomes. So that is an indication that there's a lot of waste and inefficiencies in our system. Can we go to the next slide, please? Some of the waste comes from these areas, but these are not exhaustive. For example, failure of care processes, overtreatment, administrative complexities, and failure of care coordination. And as you can already imagine at this point, from where we are in terms of all these issues to where we are expected to be, bringing efficiencies in it, it's all about decision making and choices. And big data stands right in the middle. Can we go to the next slide, please? Where is healthcare going today? Now, as we are aware of, population health is a good direction that we are going. It's one of the directions that we are going. Precision public health is another. Improved patient experience is another. Controlling of per capita costs, obviously. Evidence-supported decisions is also an area that is going to be big, which already is. Variable incentives for good outcomes, which is already being triggered by laws like Obamacare, and so on and so forth. So we are actually heading in the right direction, but the biggest enabler here is big data. The biggest enabler of these initiatives or efforts is big data. Can you move to the next slide, please? Yeah, as an example, a doctor with a patient on a bed, right, would say a heart disease. In the clinic, the information the doctor has is only electronic health records, lab records, and imaging records, and probably maybe claims records. But this doesn't tell the whole story about the patient's profile. Today, a lot of data is being collected from the patient's home, like sleep data, behavior, weight, meditation, and so on and so forth. And even in workplaces, like workplaces and vacations and wherever, and also the person's socioeconomic status and the wearables, the wear Fitbits and all, they all have a gem of information that will help improve the decision making or help give the patient's profile more practical view. So with all this information together, which is all big data, well integrated and analyzed, will give the doctor an edge in terms of his care plan, and it also get the patients involved in the decision-making process. And ultimately, the outcomes will be much better because of the insights that will come out of the data that is being integrated, processed, and well analyzed and visualized. Can we go to the next slide, please? This example is a public health example. which is also very, very interesting. Very, very, very interesting. By the way, this slide is a snapshot from MapD. MapD is now owned by OmniSky. That's why they have OmniSky at the top. The slide shows an instantaneous collection of COVID data globally, which is fed into MapD, and then MapD creates instantaneous analytics, which can be zoomed in at every area, at a continental level, country level, and even city level and district level, because this is a GIS system. So it will give you all the information you need globally, everywhere, and you can also zoom in and get the data you need about COVID. This actually helps in a disaster response for most of nations globally, in terms of resource distribution, in terms of educational need, in terms of who is at most risk and all. So this is an example of big data being used as a disaster response tool with a very global reach. Can we go to the next slide, please? Healthcare big data is all over as well. It's all over the place. You can find it in the research that we do, in genetic data, government agencies, and so on. So there's a whole myriad of information that we can get in healthcare to help in our decision-making process, to increase or improve outcomes in all different areas and aspects of healthcare. Can we go to the next slide, please? These are particular examples of healthcare data, medical journals, and databases, hold a gem of information, public health surveillance systems, electronic medical records, streaming diagnostic and monitoring equipment in hospitals or clinics, imaging data. All of these have a lot of information if one well integrated and analyzed, can give a better profile of patients and help doctors make better decisions among their patients, and then ultimately improve the health outcomes of patients, as well as at the public health level. Can we go to the next slide, please? Big data, for the most part, is a decision support tool, and it helps improve health outcomes at the clinical levels, as well as public health and all other aspects of healthcare. The list here is not exhaustive, but these are some of the ways that big data decision-making tool helps in precision healthcare, preventive healthcare, and predictive outcomes. There are several other aspects of healthcare decision-making that big data comes in very handy. The next bullet is an example of using big data to improve decision-making or to improve evidence-based medicine. IBM Watson is a tool created by IBM which processes volumes of free text from medical journals, which is capable of processing volumes of free text from medical journals. A doctor in front of a patient needs resources like that to be able to understand and also have options in terms of diagnostic and treatment, which narrows enough things down. So this compared with the evidence in front of you, from the other data improve the doctor's decision in terms of diagnosis and treatment, and ultimately improve the outcomes. Big data can improve operational efficiency, reduce waste in the healthcare system, and the costs of our financial, and improve costs in healthcare financials. Can we go to the next slide, please? As I said before, big data is a decision-making tool and it's an enabler. most practitioners in terms of helping them to make technical information to abstract insights. All of that can be done automatically by tools like Watson. There are limitations, though, of big data in that it doesn't solve any problem. However, it provides insights to help in decision making. Also, it's very noisy, and as a result of that, a lot of patterns in there may or may not be useful in the decision making. However, with the right algorithms, the right insights are slide, please. Can we go to the next slide, please? Can we go to the next slide, please? Can we go to the next slide, please?
I'm sorry, I switched the slides. Did you not see them?
So now, big data and the RCMI community. Now, big data and the RCMI community. I think we jumped slides, but what is before? What was before was how we can find out needs in big data. And I said in the previous slide that we need to assess our needs first. And once we assess our needs for big data capabilities, then we can collaborate with other parties in terms of sharing resources or utilizing their resources to research, related research. I also spoke about using cloud services like software as services or infrastructure as services to really have on-demand resources for particular research work that needs big data. These are a few of the big data resources out there in the cloud. Verica, Amazon Web Services, these are all examples of big data platforms out there that we can get on demand for research work. So can we go to the next slide, please? Can we go to the next slide, please? Yeah, so again, these are other big platforms that are also could be bought on demand for research work. Our time is getting scarce in terms of what's left, so I will just end here and let Dr. Creighton continue. So apparently we set off to get a bird's eye view of big data, and I believe together we've achieved that. Thank you very much for your audience. Sorry for the glitches, for the technical glitches.
It's okay. Thank you. Thank you, Kwasi. Okay, John.
All right. Hi. Good afternoon, everybody. So this is the second part of this afternoon's presentation. And so I will be talking about data science, but with particular focus on this grant that Dr. Sutherland talked about the training, data science training. So what is data science? If we talk about data science, if you look at the literature, some of the words you see is that is what is an emerging science. And data science starts with data, and the data aspect is what the previous speaker has just talked about. So what do you do with this data, or the so-called big data? So for research purposes, usually we are interested in what? Aggregation and exploration. What that means is you want to have a good insight into what is currently happening. by looking at the data in real time or historical data. Many times we want to make some prediction, that is, we use the data to understand what will happen in the future. Sometimes one will need to develop mathematical models and algorithms. And most importantly, we want to do what? Extract knowledge, that is knowledge discovery. And this we do through what? Data mining, or also sometimes statistical modeling, and then also hypothesis generation. But the bottom line is, from what we study from this data, we want to be able to do what? Make choices of actions and other health policy decisions. Next slide, please. So I put this slide here so that in case there are some graduate students or undergrad students who may be interested in data science. So I just put this here to encourage those individuals. Varan, who was the former chief economist at Google and also founding dean of UC Berkeley School of Information, he made a comment that the sexy job in the next 10 years will be statisticians. And when he said statisticians, he meant all individuals who are involved with data. That will include for the data scientist, the data engineer, the data analyst, the bioinformatician, so many of them. That was in 2009. And in 2012, Davenport and Patel had an article in Harvard Business Review, and the title of that article was Data Scientists, the Sexier Job of the 21st Century. And recently, I think as at June of this year, David Doden also reiterated that and said for data scientists is still the sexiest job of the 20th century. Now, if you look at, copy this from Forbes, the top 10 best jobs in the USA in 2020, you see number one was what? Says front-end engineer. I don't know what that is, but number three, no. Number three was what? Data scientist. Number 6 is what? Data engineer. But also to even emphasize on the data scientists actually held the number one spot from 2016 to 2019. So it's only this year that front-end engineer, again, I don't know what that is, yeah, just demoted data scientist to number 3 position. Next slide, please. Next. So what is data science? The NIH Office of Data Science Strategy has a definition that is what? Is the interdisciplinary field of inquiry in which quantitative and analytic approaches, processes, and systems are developed and used to extract knowledge and insight from increasing large and/or complex data sets. Data science or applied data science starts with what? Identifying relevant data sources, which is very key. And that is the part that Kwesi just talked about. Developing algorithms and or utilizing of existing software tools to access this data, and employing advanced data analytics skills for knowledge discovery and dissemination of information. Next, please. So as I said, the NIH definition said that data science is an interdisciplinary approach. So data science is in fact a team science. And then it involves what? Or it includes mathematicians and statisticians, computer scientists or IT individuals, because the computer scientists, they are the ones that will help you to do what? Write code to retrieve and then store the data. Because for us as researchers, if you don't have the data, you don't have any research. And then of course, the mathematicians and statisticians also come in with the analytic techniques, which may include regression, clustering, and so many other aspects. And then also the key part, or usually the leader of this multidisciplinary team, will be what? The domain expert, or the person with the content expertise. And this should be somebody who is experienced in the research area or the content area that the research will need to be focused. Next, please. Yeah, so I just also found this here that was explaining for the multidisciplinary nature of data science, and I hope that you find it as sexy as those individuals had indicated at the beginning. Next. So the data science workflow, I think this is where it will be very crucial or very important for us as researchers to know. I told you that it involves, it's a team science that includes for the computer scientists or the IT personnel, the statistician or mathematician, and the content expert. So all this start with what? It has to start with what? A research question. You have to have a research question because all analysis or all research begins with what? An interesting question. So what will be your research goals? What do you want to predict, or what do you want to estimate? And this starts with what? Finding the data. So this is where the content expert comes in, because the computer scientists who may help you to access the data may not even have any idea of what you are talking about. Or the statistician may not be able to help you to do the analysis without you not even knowing the data. So the content expert or the domain expert for that matter have to initiate this, come up with for the research question, the sources of the data, and then the computer programmer or computer scientist or IT person will now use their code and then appropriate software or program to access the data. Then of course there are other issues of privacy issues. Some of these databases, they are very restrictive. You have to get IRB approval. Even sometimes the computer that you'll be using, you have to document that that computer is what is encrypted. Again, if Nana Safo is on this call, he will tell you about it, that yeah, we have gone through something like that where we have to get that and then send out to NIH before they could even allow us access to the data. So once the research question is formulated, an interesting one, the domain expert tells us where the data source is. The computer scientist, that's what, write their program or do their magic to get the data. Then of course, the analysis may follow. So the data will have to be explored. We have to find out for if there are any anomalies in the data, if there are any patterns of interest that will have to be done. Then the other more advanced aspect will be building a model, especially if one needs to make a prediction or develop a predictive model. That will have to be done. Sometimes a different algorithm will have to be developed. We feed the model will need to be validated. Then of course, when the results make sense, it has to be communicated to the research community. Next, please. So data science applications in healthcare, Kwesi has already indicated some of them, but I put this here because of the training, data science training that we are going to have, because we will be getting content experts to give kind of research seminars in any of these areas. So if you're on the call and then any of the topics here, you find it interesting and then you know someone who is a content expert in any of these, you let us know, we can contact the person and then hopefully they will join us in giving this training. So one of the applications for predictive analytics, again, Kwesi talked about this, and now even with the COVID-19 data, if you go to what the Institute of Health Metrics and Evaluation in the University of Washington, they are always making prediction of what is going to happen. As a matter of fact, when this COVID-19 thing came up first, the initial prediction was that we're going to have what? Between 100,000 and 200,000 individuals dying out of that. And people were skeptical and said, well, that cannot be right, or this, and the flu curse, this. Now, what are we seeing? So now we are all seeing that the prediction actually came in as they predicted initially. This is all from data science applications. There is for data science for medical imaging. Again, these are specific content areas. If you know anyone who would want to give a presentation in this area, we'll appreciate that if you let us know. Data science for genomics, which is sometimes just called bioinformatics by some areas, but it's just still data science. So drug discovery, monitoring patient health, as Kwesi just talked about, tracking and then preventing diseases. Again, you can use for the COVID-19 as an example, and then also providing virtual assistant. There are so many tools out there nowadays that people use to make what? To get assistance on their individual disease status. Okay, next. Yeah, so that was just an overview of data science. Now the data science training program that we are going to provide. Now, if you look at data science, many of the things that we are able to do with data science now, especially if you go to the analytics. If you look at this slide here, in the middle is what? It's an artificial neural network model. Artificial neural network is not new. The theory has been around since the 1940s. But now if you look at the left and the right, we have all this programming through Python, Pandas, R, Scala, so many of them that have made life easy for the analysis. If you go to the right, Google TensorFlow, some of the things Chris mentioned, these are tools and software that have been developed that have made things easy, because the theory itself starts from probabilities. If you are talking about Bayes' theorem has been around for over 200 years. Regression models or predictive models, they have been around for so many years. But now with the advent of this advanced technology and computing, we can do things more efficiently. Next. Okay, so what are the promises, opportunities, challenges, and solutions? So the promise or opportunities for the advances in technologies and computational tools has made it possible to generate and store large, complex, and diverse data sets. Of course, data science is highly developed and it is utilized in many areas, including insurance, business, healthcare, and various areas of scientific research. The challenges are what? Writing of what? The code, the integration and linkage of heterogeneous and complex data. On the analytics side is for the bottlenecks include for validation, interpretation, and visualization. These are very crucial to extracting knowledge for inference and policy decision making. Again, because our data is big, there is always the problem of missing data. The data will always include several errors. This remains inevitable and we have to deal with it. Then there is also the challenge of what? A limited number of training opportunities. So the solution here is what? We have to be what? Collaborate or form collaboration of data science related domain experts. As I said at the earlier, data science is a team science. If even you talk about data scientists, now looking at this, I don't even know how you describe someone as a data scientist. A data scientist can only fit just one aspect of this multidisciplinary area. The person may be just a statistician. The person may be a computer science who knows how to run the code and then who understands some of the statistics or even some of the research questions. And then, of course, we have to train the next generation, the generation of data scientists. Next, please. Next. So I put this data online. This is data from 2016. This was for UA data science programs. As you can see, as of 2016, there were 10 states who had no any formal data science training program. 9 of them had just one for how to. So as of 2016, more than 50% of the United States had none or at most 2 data science programs. So this is why this training program is very crucial for us in the HBCUs. Next. Okay, so these are just the programs in the DC area here, only a few institutions. If you go further north, Maryland and Hopkins have these programs as well. Next. Again, next. Okay, so what is the significance of the training institute? As we can see even from the programs, there are disparities, and this is particularly prevalent in minority institutions. Most of the schools with the 0 training, most of them are in the South. Mississippi, those are areas where we have several minority institutions. So the skill sets are needed. The ability of our researchers to recognize and use big data is very limited. So again, recognizing the data, because many times we don't even have any exposure of where to look for this big data set. Of course, there is the knowledge of the programming, there is a lack of expertise in advanced data analytics. Next, I understand my time is limited now, so I'll go to the next. I've just talked about the aims. Yeah. So the aims of this training institute is to build capacity in data science in minorities serving institutions by providing this training to both Howard and then extend it to the national RCMI community. 2 is to foster collaboration in data science among researchers in minority institutions. The 3rd aim is just the marketing aspect. So next. So our approach is to launch an 8-week comprehensive training series. This will be in a virtual setting, of course, because of what we are all going through now. Faculty will be drawn with complementary expertise from different institutions. We will also partner with the NIH Office of Data Science Strategy to deliver these lectures. And then, of course, the lectures are going to be free. So if you know of any person who may benefit from this training, just pass along this to them. Next. Next. And then the training will be designed in modules in the sense that each module will be very separate. So if you find a module that may not benefit you, you can skip that and then just be in the next module. So that we break this down into 4 parts. So the first part will just be the programming tools for data science. This is where the IT people become very relevant to us. Part 2 and part 3 are just basic or advanced statistical approaches that are used to conduct data science research. And then the 4th part will be presentation on current research topics. So again, if there are any specific research area that you want us to cover, and that you know somebody who had that content expertise, you let us know. We'll contact the person. Maybe the person can point some pointers to where we can find some of these data sources. Again, as I said, and if even you look at the literature, one of the key issues is finding those data sources. I believe that's, yeah, next. Okay, so that is just the Swahili word for thank you, asante.
Thank you very much, John. I think we had a question or two from in the chat. Can we handle those chat questions first?
Sure.
So the first question is there a difference between predictive modeling and machine learning?
No, there's not a difference. Machine learning is just a higher level approach of fitting a predictive model. Now, we talk about data science, the analytic methods. What is predictive model? The predictive model can just be based on simple regression analysis. But why is it that in data science is different? Because data science, we use methods we call what unsupervised learning. That is what most of us will do if you are fitting your logistic regression or linear regression. But if you are doing machine learning or even deep learning, then you have to do what? Do a supervised model. Supervised model is where you break your data, the same one data set, into 3 parts: the training model, the validation, and then the test model. So the answer to that question is no. Machine learning on predictive model can be done, or is done in data science.
Okay. I'll do one more chat question before we open it up. When will the VADSTI trainings begin? So from your grant that has just been, you've just received, when will you start your trainings?
Yeah, we plan to do this in the spring of 2021.
Okay. All right.
Another question, you have presented 4 areas where one can learn about this data science. For many of us without a very strong background in mathematics or statistics, where will you recommend for us to start? For instance, programming, that belongs to the realm of computer.
Right.
And many of us, I mean, I struggled to write basic or Fortran many years ago. I can't even remember it. So do you think such things will be relevant to us?
Well, that is why the training is divided into modules. So for you who have been in this research business for so many years, you are not going back to learn how to write a code. Again, I also said that data science is what? It's a team science. There is no one person who can call themselves a data scientist, even though we do that. But it's a team science. So for you, you don't have to write a code. You have a lot of, I know you have a lot of research funding, collaborate or hire a computer scientist, then you direct them to get access to the data for you, and then you take it from there. You don't have to go back and then learn how to write a code. So when the training is beginning, you can skip that part altogether, unless maybe you find it as a hobby to learn that, then you can do that.
Thank you.
Any more questions before I go back to the chat?
Yes, if I can also follow up along the same lines as Dr. Akala. So again, as a basic scientist, trying to think about data science, I mean, you are talking about huge, humongous data. So my question is, in really coming up with a scientific question, do you suggest that we sit with computer scientists as well as mathematicians to really even begin to coin our questions to make it relevant to use the data science? And perhaps this is something you're going to cover in the VADS training?
Yeah, of course. The research question or the hypothesis statement, for that matter, anytime we talk about these things, it has to be formulated in a way that it makes sense and is also what is testable. Because if you are testing a hypothesis, it has to be written in a way that the key variables are presented. If there is an association that is clear, if there is a you are predicting, all those things will have to be clear. Because without, unless maybe the person is doing qualitative studies, but if you are doing quantitative, the variables, the very key variables will have to be clear in the research question itself for the computer scientists to know what variables they would need to do what, extract. Of course, you sit down with them and then they tell you, okay, from what you've written, this is the variable you want to extract. Is that right? Then once you give the go ahead, then they go ahead and then extract that for you.
So John, let me follow on that. For a non-computer type person, like Bernard said, he's a basic scientist. So if you have a question, the way I think about it is that I have something I want to find out. I have a question that I want to resolve.
Right.
Now, I can articulate that in my own language, in my own words, but I may have trouble articulating that in a way that can be implemented computationally. So in order to formulate that question in a way that can be implemented computationally, I may need some help. I may need to go to somebody like John or Quasi to really express that, okay? So,
right.
So you got to think about it. I won't get too hung up on the technical aspects of it, you know. Just think about, can you express what the question you want to answer in your own words, in your own terms?
Well, sometimes you may not be able to do that. That is why it's always good, or it's always better to communicate with the statistician or the computer scientist to get an idea of what they are trying to get. Now, I think I saw Kara on the Zoom. I don't know if she is still on it. A grant that the sport grant that was submitted recently. I think Bernard is also part of that grant. This was Howard Hopkins grant, and then there were 3 projects. And then for each of the projects, we had to meet with the project leaders multiple times, because they write it, I read it, certain things, maybe they may put in like, okay, so I want to do 18 by 30 design. Then you ask yourself, what is this 18 by, where is that coming from? But once you sit down with them, you communicate. It doesn't have to be a 15-minute. If it is 15 minutes, then maybe it's not that complicated. But the communication is very important right from the start, to know where they are going, and for you, the statistician, or for that matter, the computer scientist, to know which variables you are looking for.
I have one question.
Sure.
So, and I'm sorry for missing your large part of your talk. So I just have questions. So do you, could you please recommend one concise textbook on the data science so I can review quickly to see whether I can make it by learning, or just develop collaboration with you or other data scientists?
Yeah, I can look for one for you.
Okay.
But again, as I said, that data science is very broad. It's not as focused as so many people might think. There may be a textbook just on data visualization. A textbook on, let's say, there may be a textbook that says Python and data science. Now, I say Python and data science, then it means that you are interested in what? Writing the code, using Python to write a code to do some descriptives or to run some regression analysis. So it's broad, but I will see if there is any one of those books that they call what? For dummies or whatever. Not you, I don't mean you.
To complement Dr. Kwajan's answer, data science is a very broad domain, and it's multidisciplinary, as he has already said. But to be able to know what you actually need, you have to assess your needs before you even go to the capabilities that you may need. So the first step is to determine what you need in research or in your area. Then there are several things out there that can help you achieve that goal. But if you look at it from the broader perspective, you will get lost. You will be all over the place. So you have to assess your needs first, and then look for resources or capabilities that will help you meet those needs or goals. Thank you.
All right, any more questions?
Yeah, I have a question.
Oh, go ahead. Mm-hmm.
Good evening, good afternoon, sorry. And thank you all for the presentation. I think I may have missed this part. Is there any space in some of the work I've seen that talks about looking at bias and ethics and how we make sure we're asking the right questions? I'm coming from African American studies and I haven't kind of transitioned into, let's say, data science, but is there any space for that work in the training, I guess, around understanding if the questions and data is representative enough, or?
Oh, yes, the training will provide that. Again, if you saw in my presentation, even accessing the data itself, there is an ethical issue there because, again, privacy is always an ethical issue. What are you going to do with the data? That is why I said that even sometimes some of the data sources, the computer, has nothing to do, the computer itself will need to be encrypted with double password. And we had to go to the iLab or wherever for them to do that. And then Dana, for the research person, what is her name? She had to,
Dana Hector?
Yeah, Dana Hector, she had to acknowledge that, yes, we went to the computer science people for them to encrypt the data before we could get access to it. So ethics is always key, and then, yeah, we will talk about that.
Thank you.
All right, any more questions before I turn it over to Dr. Sutherland?
Okay, I want to thank everybody for coming, and thank Drs. Carnell and Lee for kind of putting this together, and Stacy in the RCMI office for kind of helping us out with this, and also Kish